last thing. There's two parts to this. The last part of the domain and the range is if you're given the actual function itself, how do you identify what the domain and the range is? So we have to finish with that, and then we have to move to function notation. And that's going to be the end of chapter 3. Okay, so we went through all of this stuff. So remember we talked about functions. How do I tell if something is a function or not? Don't put this in your notes because it's already there. Is this a function? Yes or no? Yes. Is this a function? Yes. Is that a function? No, why not? Right, because we've got 2, -2. So we went through all of that. Identifying domain and range. Here my domain is what numbers? 3, 4, and 6. My range is -1, 2, 5, 8. Is that a function? No, you got 2 4s, right? Domain and range this way. Domain would be 1, 2, 3, 4. Range would be DBA or ABD if you put it in alphabetical order. Good, then we went through all the different types of graphs. Okay, did the vertical line test. Now let's talk about different types of functions. So, the first function we are going to be focusing on is a linear function. You can just make a rough sketch of a straight line. It does not need to be this exact line. Okay, if you are having a linear function as your function, you have to identify domain and range. Okay, notice I have arrows both to the left and to the right. Is there any endpoints for either of my x's or my y's? No. So my domain for any linear function, oops, I'm in highlighter mode, is going to be all real numbers. Okay, so linear functions, doesn't matter what it is. What does a linear function look like? Well, let's say this has a slope of what? Down 1 over 2, so -1/2. So let's say this is y equals -1/2 x. My y-intercept is 1/2, so plus 1/2. Let's pretend that's the function. So a linear function, what is specific about the exponent on the x term? What is the exponent up here? 1, right? Linear functions always have an exponent of 1. So whenever you see a linear function, whether it's y equals -1/2 x plus 1/2, or it's y equals x, or it's y equals 2x minus 5, whenever you see a linear function, your domain will always, always, always be all real numbers. Okay? Linear functions. All right, quadratic functions. What does a quadratic function look like? A parabola, right? Y equals x squared. So it's a parabola, the u. So quadratic is our parabola. So y equals x squared. If I'm talking about the domain of that function, does it have any endpoints? I know there's not arrows there. That's what I get for stealing stuff off the internet.
0.
Well, that would be the range, right? But for domain, there is no stopping point for the left and the right. So our domain again here, so domain is going to be all real numbers. It's the range that would be from 0 to positive infinity in this case.
Okay, if I just write all real numbers instead of negative infinity, positive infinity, because I write crappy infinities.
I would prefer you to put it in interval notation. Okay. So any quadratic function, doesn't matter what it is. It could be y equals 3x squared plus 2. It could be y equals 3x squared plus 6x plus 5. As long as it's a quadratic function, your domain will always, always, always be all real numbers. All right, so now let's get to the little bit more tricky ones. Rational functions. So your rational function graph ends up looking like this. And here the function is y equals 1 over x. That's an example of a rational ratio, writing something as a fraction, right? So a rational graph is where you have your variable in the denominator. Now here you do have something very specific about your domain. In this case, what number can never, ever, 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 ever be in the denominator? 0, right? So in this case, I'm going to set my denominator equal to 0, whatever that may be. And then I'm going to say whatever numbers it is to 0. So in this case, x will never equal what? So it's going to go to negative infinity to 0 with a parenthesis because it can't be 0. Now how do I get this right side? And it's going to be from 0 to positive infinity. And then what do we do in between? We're talking about the union of these two intervals. We put the little u. Okay. If I change this into y equals 1 over x plus 1, now what's the number that it could never be? 0 is okay now, right? Because 0 plus 1 is 1. What number makes me not get, or makes me get a 0? If I set this equal to 0, it's going to be negative 1. So how do I do my interval notation to not include negative 1? So just change it. It's going to be negative infinity to 1 union 1 to positive infinity. Right? Because I need to exclude just that one value. In this case, or sorry, it's negative 1, not positive 1. Negative 1 plus 1 is 0. Okay, so rationals. You're going to set your denominator equal to 0. And you should put a little star there. Set denominator equal to 0. And then that's the number that you are going to exclude. And to exclude it, we put parentheses around it. We're setting the union of everything to the left and everything to the right. Okay. All right, the last one we have, instead of rational, we're going to do radical. Your radical function is not going to be all real numbers again. It's going to be something a little bit different. Okay, so an example of a radical would be something as simple as y equals the square root of x, which is what this is looking like. If I had to write the domain of this, I would be starting where? At 0 and going in the positive direction to positive infinity. So it's all the positive numbers, right? So I need to decide what value is going to make everything be positive. So instead of setting it equal to 0, I'm going to make it greater than or equal to 0. So how do I write this as interval notation? It would be bracket 0 to positive infinity. Okay. If I added something underneath that radical sign, let's make it x plus 1. Set that greater than or equal to 0. So I'm totally ignoring the square root sign. So if I solve this inequality by subtracting 1, I get x has to be greater than or equal to negative 1. How do I write that in interval notation? Bracket negative 1 to positive infinity. So it's the rationals and the radicals that are going to get a little tricky. Quadratics and linear are very simple. Okay, so let's go through some examples and see if we got this. All right, example 1. What's the domain going to be? What type of function do we have? Linear, so it's going to just be domain is all real numbers. Any linear function. Domain will be all real numbers. Yes? So y equals x plus 4. Domain is negative infinity to positive infinity. Okay? I don't know if I'm moving too fast. Next one. We have y equals the square root of 2x minus 1. So this is a radical function. So that means we're going to take whatever is underneath the radical sign and set it greater than or equal to 0, because it needs to be positive. You never can take the square root of a negative number. So adding 1 to both sides gets me 2x is greater than or equal to 1. Dividing by 2 gets me x is greater than or equal to 1/2. So how do I write that in interval notation? Good. So there would be my domain. So my domain is bracket 1/2 to positive infinity. Good. All right, let's do a quadratic. Y equals x squared. What's our domain? Good. All real numbers. So negative infinity to positive infinity. And then we'll finish with a rational. So y equals 5 all over x minus 1. Because I'm focused just on the domain, I'm just going to focus on the denominator. Set that denominator equal to 0. Add 1 to both sides. So I get x is equal to 1. So that means x cannot equal 1, right? Because that would get me 0 in the denominator. So I need to exclude everything but 1. So negative infinity to positive 1. Union 1 to positive infinity would be your domain. Okay?
So the 5 doesn't matter?
5 does not matter, no. That won't affect your domain. The only thing I care about is the denominator in your domain. Okay? Do you need to practice these, or should we move on to function notation? Yes, no?
Move on.
Move on? Is everybody with Hannah? Are we sure? All right. Okay, do you guys remember function notation? Y equals f of x. So function notation is no different than just your regular y equals notation. It's the same thing. Y and f of x are the same exact thing. So sometimes it's nice to think about it. You're used to writing an ordered pair as x comma y. Well, if we put it in a function notation, it's going to be just the same as x comma f of x. These are the same exact ordered pair. Regular notation, function notation. So your y turns into an f of x. And the reason why we use function notation is if you're talking about a whole bunch of different functions, you can change this letter f to function g, function h, function r, function s, and then whatever number is inside the parentheses is the number that you're using to represent your x variable. Okay, so you got your input and then you get your output. Okay, so let's see what we remember about function notation. If I give you a function f, so f of x equals negative x squared plus 5x minus 3. Can you find the following outputs? So f of 2. So if I want to find f of 2, that means we're going to input the number 2 in place of x. That's what that means. Or I guess I should have used the word substitute. So f of 2 is going to be equal to, all right, the negative is not included in that square, so I'm going to keep it outside of my parenthesis. So I'm going to take 2 squared and then the negative of it, plus, so negative 4, right? 5 times 2 minus 3. So 2 squared is 4,
So 2 is 3.
negative 4 plus 10, which is 6, minus 3. Yeah, so we got f of 2 is equal to 3. What would that look like as an ordered pair?
3 comma f of 2?
Nope.
No.
What was the x?
2.
2. What was the output when we put 2 in?
3.
3. So if I were to graph that, it would just be the ordered pair 2 comma 3. That's all this is. Just fancier notation. So f of 2 is 3. That's our output. 2 was our input. All right, let's do fq. So wherever I see an x, I'm just going to put in a q. So negative q squared plus 5q minus 3. Because my input was another variable, I can't evaluate anything, so that's my final answer. So f of q is equal to negative q squared plus fq minus 3. Okay, so don't let those variable ones stump you. Those actually are the easier ones because you're just rewriting the variable in a different letter. All right. What if I gave you something like this? G of x is equal to 2x plus 3. Question? Oh, just stretching, Maddie. Yes. And I want you to evaluate g of a plus 1. So g of a plus 1. So that means wherever I see an x, I'm going to substitute in place of it a plus 1. So let's rewrite this. So I have a 2. 2 comes down. Sorry, Mr. Morrell. Bring down your a plus 1. Bring down your plus 3.
So it's just 2 of a plus 3.
2 of...
2a plus 3. 2a plus 5.
Yeah, so 2a plus 2 plus 3, right? Distributive property. Simplify 2 plus 3 gets you to 5. So g of a plus 1 is equal to 2a plus 5. All right, so given a function in function notation, hopefully you can evaluate it for some type of input to get some type of output. Now, let's talk about function. Now, you've probably seen that before in Algebra 2. Now let's go to in different formations of it. So here's a set of ordered pairs as your function. So we have function f, given the ordered pair negative 3, 5, 0, 3, 3, 1, 6, negative 1. And I want you to tell me what f of 3 would be equal to. So f of 3. Any guesses? So remember, this represents which variable? Your x. So when I input a 3 for my x, what comes out? When I input 3 for my x, what comes out? 1. Right. And didn't I say in that first example, this as an ordered pair would just look like that? 3, comma 1?
So basically, don't overthink it when it comes.
Don't overthink it. Okay?
No, I need to write all that crap down.
All right, so given an ordered pair, so if I said, what's f of 6? You would say it is negative 1. What if I did it backwards? Are you ready for this? What if I said f of x is equal to 5? What's your x?
Negative 3.
Yeah, your x would be equal to negative 3. Does everybody see that? So x is equal to negative 3, because if my output is 5, my input would have to be negative 3. So you can do it both ways. All right. What if I give it to you as a mapping diagram? So here my domain is negative 2, 3, 4, 10. And in the first bubble, my second bubble has negative 1, 0, 2, 4, and 6. Negative 2 matches with negative 1. 3 connects to 0. 4 connects to 0. 4 connects to 2. 4 connects to 4. So right there, that makes it not a function.
Would you
I
continue
shouldn't have
then?
said. Yep. I shouldn't say function though. So and then 10 continues to 6. So I want to find f of 3. So what would f of 3 equal in this mapping diagram? Good. Because your 3 for your x matches up with 0. Okay. So ordered pairs, mapping diagram. The last thing we got to cover is when it's in an actual graph. So are we okay? All right. So if I give you a graph, this is linear. So my domain is all real numbers. My y-intercept is at 1, and it's going up 2 over 3, so your slope is 2/3. So just put a quick graph there at 2 or 1, up 2 over 3, up 2 over 3, and go down 2 over 3, down 2 over 3. And we want to find f of 3 once again. So that means at my 3 on my x-axis, I'm going to go up to see what my output would be. In this case, it is also 3. What if we did it backwards? What if I wanted to find f of x such that it's equal to -1? Yeah, so go to your y being -1. What is your x? It would be equal to -3. You see that? Yes? No? Maybe so? All right. So, function notation. I'm going to have you